Hello and welcome to a problem review of CNCM Online Round 1. This is CNCM Online Round 1 Problem 4, written by me, Akshar. So let's move on. Alright, so the problem reads, consider all possible pairs of positive integers a, b such that a is greater than or equal to b, and both a squared plus b over a minus 1 and b squared plus a over b minus 1 are integers. Find the sum of all possible values of the product AB. All right, so just to start, we want to look at both of these. We want to make these integers clearly. So let's look at the first one here, a squared plus b over a minus 1. So first of all, we can simplify this a bit. So here's the thing. Note that a times a minus 1 is equal to a squared minus a. We know that's true. Um, and our numerator has an a squared term. So we can take the numerator here. Oops, sorry. We take the numerator here. We can write it as a squared minus a plus a plus b, because this is equal to a squared plus b since the a's cancel. However, this is all over a minus 1. We know that a minus 1 times a is equal to a squared minus a, so we can actually rewrite this as a plus b over a minus 1. And now clearly a is an integer, so we can disregard the a because we're just focusing on making this an integer. And we're going to keep on doing this. So we want to get, also, we have the denominator a minus 1. Let's see if we can remove the other a term in the numerator. And we can, since a minus 1 times 1 is equal to a minus 1. So we can rewrite this as a minus 1 plus b plus 1, since the 1's cancel and our numerator is still equal to a plus b, all over a minus 1. Now, once again, this is equal to 1 plus b plus 1 over a minus 1. And we can disregard the 1 since if this whole thing's an integer, this part right here must be an integer as well. So we've brought this down to its simplest form, b plus 1 over a minus 1. This is much more simpler to work with than a squared plus b over a minus 1. And whenever you see a problem like this, you want to try to remove the terms in the numerator like we just did. Now, we're just going to focus on making this an integer. So, let me move on. Before I move on, note that b squared plus a over b minus 1 is the same thing, but with the variables switched. So we can actually write this the same way as this. We can write it as a plus 1 over b minus 1. If you're not convinced, you can do the same process we did with the first fraction here and get this, except with the variables switched. So now, moving on, we have the first fraction simplifies down to b plus 1 over a minus 1. We want to make this an integer. And then the next part is a plus 1. The other fraction simplifies down to this, a plus 1 over b minus 1. So we want to make these both integers. If these are both integers, then these two quantities right here are also integers, since, well, an integer plus an integer is equal to an integer. So, we want to make these both integers, and we didn't really know how to start here. Let's see if we can get some bounds for a variable, and we can see if we can progress there. So clearly, if this fraction here was to be an integer, then b plus 1 must be greater than a minus 1, because you can't have a number divided into a smaller number. A number must divide into a larger number. This is pretty obvious if you look at it. So from this, we have b plus 1 is greater than or equal to a minus 1. If I want to give you an example, 3 can clearly not divide into 2 because 2 is smaller than 3, but 3 can divide into 6 because 6 is larger than 3. It seems obvious, but we're going to write this so we can get a bound on our variables. And similarly, we can write a plus 1 is greater than or equal to b minus 1. Let's put these in terms of a. So we get b plus 2 is greater than or equal to a. And we get A is greater or equal to B minus 2. Now the problem stated that A is greater than or equal to B. So let's keep that in mind. So if I actually combine these together, well, before we do that, you can see that, well, B plus 2, sorry, wait, disregard what I said. So let's just put this in terms of A. Like we'll combine these two inequalities. We can do that. So we get B minus 2 is less than or equal to A is less than or equal to B plus 2. This is just combining the two inequalities. And yeah, since A is greater than or equal to B, we can actually disregard this bottom part. Since B minus 2 is, well, smaller than B, so we can actually make this bound stricter. We get B is less than or equal to A is less than or equal to B plus 2. Now, we have a pretty tight bound for A. We can actually now break this into three cases, this problem. A equals B, A equals B plus 1, and A equals B plus 2. So those will be our three cases. Moving on. So remember that our fractions were B plus 1 over A minus 1 and A plus 1 over B minus 1. So let's solve this for the A equals B case. Well, if A is equal to B, then we can rewrite these as A plus 1 over A minus 1, and this ends up being the same thing, A plus 1 over A minus 1. Since they're both the same thing, we can do this. So now we have this one fraction that we only need to make an integer. Now, this seems much easier to do. And if you see from before, when we actually simplified the original fraction, we can actually simplify this as well since there's an a in the numerator. So we can rewrite the numerator as a minus 1 plus 2 over a minus 1. Now this is equal to 1 plus 2 over a minus 1. Clearly 1 is an integer, so 2 over a minus 1 must be an integer. So how do we do that? Well, it's fairly simple. So the only numbers I can divide into 2 are well, only 1 and 2 divided into 2 that are positive integers. So that gives us that a is equal to 2 and a is equal to 3 because 2 minus 1 is 1, 2 over 1 is an integer, 3 minus 1 is 2, 2 over 2 is an integer. So now we have our solution. Since a is equal to b, we have 2, 2, and 3, 3. Those are our two solutions for this case. So let's keep that in mind. We'll just box these in. All right, so the next case is a equals b plus 1. Moving on, we want to make b plus 1 over a minus 1 and a plus 1 over b minus 1 integers. And we have that a is equal to b plus 1. So substituting this in, we'll just substitute a equals b plus 1. We get b plus 1 over b from the first fraction, and we get b plus 2 over b minus 1 from the second fraction. Now, note here that b plus 1 divides into b. We can simplify this, but b is already in here. So this is actually equal to 1 plus 1 over b if you split the fractions. And that means b must divide into 1 and b must be 1. But we're looking for solutions that both of these two fractions share, because both of these must be integers, not just one. So b equals 1 clearly doesn't work here because b minus 1 will become 0, and you can't have 0 in the denominator. Let's just look at this case real quick and we'll see what happens. We write down that b is equal to 1 as a solution for this. B plus 2 over b minus 1, we can rewrite that as b minus 1 plus 3 over b minus 1. And that gives us that b minus 1 must divide into 3. And for that, you have only two integers that divide into 3, 1 and 3. That yields b equals 2 and b equals 4. Using the same problem as last time. But here's the thing. We need b values to be shared between the two fractions. B equals 1 makes this first quantity an integer, but doesn't make this second quantity an integer. The problem says we want both of these to be integers. So clearly, since these have no common solutions, this case actually has no solutions. So let's move on to our final case. A equals b plus 2. Let me just write in our fractions here. All right, so we want to solve for a is equal to b plus 2. So let's just sub these in. The first fraction becomes b plus, sorry, oops. Okay, b plus 1 over b plus 1, since b plus 2 minus 1 is b plus 1. Now this is always true. This is always an integer. So that's good for us. Let's move on to the next one. We have b plus 3 over b minus 1 must be an integer. Now, this is the only thing we have to solve for, since this is always an integer, so we don't have to worry about this. So whatever solutions for b we get will obviously work here, since this is just 1, basically, it's just 1. So whatever solutions we get here will be our total solutions. So let's move on. Using the same process as we have done, we can rewrite the numerator as b minus 1 plus 4, because that's equal to b plus 3, all over b minus 1. This gives us 1 plus 4 over b minus 1. And that means we're trying to make 4 over b minus 1 an integer. So there's three integers that divide into 4. That is 1, 2, and 4. So real quick, let's just go over here to the left. If b minus 1 equals 1 yields b equals 2, b minus 1 equals 2 yields b equals 3, and b minus 1 equals 4 yields b equals 5. And these yield the corresponding a values of a is equal to 4, a is equal to 5, and a is equal to 7. So this gives us the pairs 2, 4, 3, 5, 5, 7. So if you go back to the problem, let me just erase all this. So we have some space. We have covered all three cases. So we've received 5 solutions. The first case had 1 solution. The second case had no solutions. No, the first case had 2 solutions. The second case had 0 solutions, and the third case had 3 solutions. So we've covered all our bases with our bounds. And now we have to get the correct answer from these. So let's just list our solutions here. We have 2, 2, 3, 3, both from the a equals b case. And we have 2, 4, 3, 5, and 5, 7 from the a equals b plus 2 case. So these are our 5 solutions right here. And we want to find the sum of all possible values of the product AB from our pairs. So, well, the product here is 4. This is 9. This is 8. This is 15. This is 35. Adding this up, 35 plus 15 is 50. 50 plus 8 is 58. 58 plus 9 is 67. 67 plus 4 is 71. And that is our final answer. Before we end this video, I just want to say that whenever you see a problem like this, your first step should be to completely simplify the numerator here. We were able to remove all the a terms from the numerator here and proceed. And when we worked with our specific subcases with a equals b plus 1, a equals b plus 2, we were able to repeat the same process again. So always simplify down the numerator whenever you want to make this, make these expressions an integer. And also know that the power of bounding, it's very powerful. Like we couldn't solve this standalone. This has so many solutions. We don't know where to start. But since we were able to bound A, we were able to break this into three simple cases and solve the problem. So whenever you see problems like this, you want to do those two steps. Those are the two key steps that you want to do. So that's it for this video. If you do like our content, please do like and subscribe, and please do join our Discord of 1,000 members. We have problem of the day, and we have all our CNCM upcoming competition updates. We're planning to hold a CNCM online round 2, and we'll be releasing details about that later. I hope you did enjoy the problems of CNCM online round 1. This is solution video for problem 4. Solution videos for problems 3, 6, and 7 will be coming out soon. Thank you for watching. See you next time.